Good day, everyone. I am RIZA PIOL, and today we're going to explore the fascinating concept of forces and fluids. Did you know that pressure applied to a fluid can be transmitted equally in all directions? Join me as we uncover the remarkable way forces travel through fluids by exploring Pascal's principle. To guide our discussion, we have a clear main objective: to apply Pascal's principle in analyzing fluids in various systems. In physics, pressure is simply the force applied perpendicular to a surface divided by the area over which the force is distributed. In graphic A, the force from the finger is spread out over a large area, so the pressure is low. On the other hand, graphic B, the same force is focused on the tiny, sharp point of the drawing pin. This concentrates the force onto a very small area, creating a high pressure that can push into the wood. In simpler terms, pressure is a measure of how concentrated a force is. The formula for pressure is P equals F over A, where P is pressure, F is force, and A is area. We measure pressure in pascals or newtons per square meter. Now, who was Blaise Pascal? Blaise Pascal is the brilliant individual whom Pascal's principle is named after. He was a French mathematician, physicist, and philosopher. Pascal made significant contribution to many fields, but his work on fluid mechanics, specifically his formulation of Pascal's principle in 1653, is what we are focusing on. His discoveries were foundational, giving us the tools to understand how fluids transmit forces and enabling the development of many technologies we use every day. So moving on to our main topic, Pascal's principle. Pascal's principle, also known as Pascal's law, states that when a change in pressure is applied to an enclosed fluid, it is transmitted undiminished to all portions of the fluid and to the walls of its container. In simpler terms, imagine a closed container filled with a liquid like water. If you apply a push or pressure at one point in that liquid, that exact same pressure instantly and equally spread out to every other point in the liquid and also pushes on the walls of the container. It's important to remember this applies to fluids that can't be compressed, like liquids, and that are held with a confined space. This equal transmission of pressure leads us to the following formula. Since the pressure is equal throughout the fluid, we can say that P sub 1 is equal to P2 sub 2. Using substituting our pressure formula from earlier, P is equal to F over A. This means that A sub 1 over F sub 1 is equal to A sub 2 over F sub 2. Here F sub 1 is the input force applied to an area A sub 1, and F sub 2 is the output force exerted over an area A sub 2. What this formula tells us is that a small input force applied to a small area can be transformed into a much larger output over a larger area. This is the magic of force multiplication, and it's the core idea behind many powerful machines. First, we have the hydraulic lift. A person applies a small force to a small piston or the pump handle. This creates pressure in the hydraulic fluid. The same pressure is then transmitted to a much larger piston. Because pressure equals force divided by area, a large area with the same pressure will have a much larger force. allowing the large piston to lift a heavy car or the other object with minimal effort. A hydraulic press works exactly the same way, but instead of lifting, the powerful force is used to press or crush materials. A small force applied to a small piston creates pressure that is transmitted to a large piston, generating a massive force for tasks like forging metal or compressing materials.
So here is the sample problem.
So the given is F sub 2 is equal to 3,700 Newton, A sub 2 is equal to 2.8 meters squared, A sub 1 is equal to 0.72 meters squared. The required is F sub 1.
So in order to get what is asked based on the problem, here is the solution.
To summarize, the key takeaways for today are: I hope this presentation took the pressure off of understanding Pascal's principle. Thank you for listening.